Righteous. Righteous. Excellent. Okay, cool. Sweet. Grand. From the 403 to the HAZ, Mr. Nelson. Really excited to be basically finishing off the logarithmic unit because it's very foreign to me. I haven't dealt with logs in a while, and I was figuring it out along with you guys. But it's not so bad if we have our laws in front of us. The last video, we were learning how to solve exponential equations using logs, and that's exponential equations where we have different bases with exponents. So when we had different bases, we had to use logs. When we have the same base with exponents, we can just go straight to our c to the x is equal to c to the y, therefore x is equal to y law, that we recall. Green is just a weak color, but I want to use it. So we're going to now solve logarithmic equations, equations involving logarithms. And we're going to do that just based on what we know so far, what we've learned about the laws of logarithms. This should be enough to allow us to pretty painlessly solve logarithmic equations. However, there's one extra identity or law that's going to come big time in handy for us, okay? And that is log base c, when log base c of some number a is equal to log base c of some number or expression b, that means that a must be equal to b. They're very similar to our exponent identity, okay? And this just comes from everything we've done. I'm not going to prove it to you because I'm an engineer and I just want to use the math. So let's just use this identity. We don't all have to be Stephen Hawking's or Einstein's. The world does just need engineers sometimes, people to use the math, and that's what I'm here for. You're judging me, I can feel it. Okay, in any case, this is going to come in handy. So let's just start solving logarithmic equations. And I'm going to go straight from the textbook. Let's start basic here, okay? I have log base 6 of 2x minus 1. And that is equal to log base 6, 11. Okay. I'm like, ooh, there's a lot going on here. But what I notice right away is both these logs have the same base, 6, which is very similar to this law. So therefore, whatever's here must be equal to there. So I can ignore the logs now and just say, okay, well, based on my rule or identity there, 2x minus 1 is equal to 11. And now I can just solve for x. 2x is equal to 12, therefore x is equal to 6. Great. Great. Okay. I am going to get into restrictions on the variables in another video because I just don't feel comfortable doing that right now. I'll get there. In the next video will be restrictions on variables, okay? Because that is something that they start asking us for. Essentially though, yeah, we'll get into that because I'm not comfortable. And that's okay. It's okay not to know stuff. We learn it. So let's do another example. This was really easy, right? Not so bad. So let's try a different one. Okay. Now I have log of 8x plus 4 is equal to 1 plus log of x plus 1. Okay, I'm going to move all my logs to one side, okay? Because I know when I do that, I'm going to be able to use this to rewrite this, because they have the same base of invisible 10 here. Remember, when there's no base, you assume 10, because we are in a base 10 shared reality. So I get log 8x plus 4 minus log x plus 1 is equal to 1. Okay, so I'm basically bringing all my x's to one side, and I do that by bringing all my logs to one side, because that's where my x's live. Now I can use my law here to rewrite this. So log of 8x plus 4 divided by x plus 1 is equal to 1. Okay? But what am I doing here? Right. So this is log base 10. How do I get 1 from a log base 10? Well, I'm going, because I want these to both be, I want to basically get this into a form where I can use this law here, okay? So that I can get rid of the logs. So I need to write 1 as some log with a base 10. So here, 1 is the same as log base 10, 10. Because that's going to give me 1. So I can write it log of base 10 of 10. There we go. So now I can use this law here, and I can rewrite this. I can basically ignore the logs now and just write it as 8x plus 4 is equal to x plus 1 is equal to 10, because I ignore the log part. Okay, now I can solve for x. And to solve for x, let's first get rid of the denominator. So I'm going to multiply both sides by x plus 1. And then I get 8x plus 4 is equal to 10x plus 10. And to solve for x, I'm just going to bring all my x's to one side and all my numbers to another. So I get, I'm going to subtract 10 from each side, and then subtract 8x from each side. Then I get negative 6 is equal to 2x. And then I divide by 2. And I get x is equal to negative 3. Okay, so what did I do here? Well, basically, the first step I'm going to do is I'm going to try and get all my x's over to one side, regardless of if they're inside a log or not. So I had to move my log all the way over here. And I'm going to move all of my constants to the other side if I can. Then I see what identities I can use here to simplify this expression. And then I'm going to try and get to the other side into this form, into a base of the same logarithm. So let's do another example, because this is my first time doing this too. Okay? First time since my first time. Okay, let's try. Do some textbook problems here. Let's try. I'm going to try and do not so easy ones. So let's try, here we go. Okay, I've got log base 5 of x minus 18 minus log base 5x is equal to log base 5, 7. Okay, so the first thing I notice about this equation is they're all base 5, that's a really good thing for me. I can work with that. And I already have all my x's on one side of the equal sign, so bonus. So what I'm going to do then is I'm going to figure out which identity I can use to simplify. And it looks like I've got subtracting with the same base, so I can rewrite, let's use some red. I can rewrite this as log base 5 x minus 18 divided by x. And that is equal to log base 5, 7. Now in this case, look at this. I'm already in this form. I didn't have to do anything here because I already had that base 5. Great. So I can use my identity here. Log of some base of A is equal to log of the same base of B. Therefore, x minus 18 over x is equal to 7. And then I can multiply both sides by x, and then I can solve for x. So I get x minus 18 is equal to 7x, subtract x from each side, I get negative 18 is equal to 6x, divide both sides by 6, and I get x is equal to negative 3 again. Okay? Do another one. And I get anxiety doing these because I'm doing these all, I know I keep talking about it, like it's, sometimes I'm middle of a video and I'm just like, I don't even know how to solve this. And then I get really tense because these videos are hard to do in one take, but I do my best. Anyways, okay, let's just try another one before, so I can get more confident before we move on. Confidence is so key in math that sometimes when I'm struggling, I take it back, I go back to basics, I start rebuilding my knowledge and hope that the momentum of relearning stuff and getting it into my head better will help me advance. Little strategies we develop. Okay, here we go. Again, I'm noticing I've got base 2 here and here. Okay. And so I have my number over here. So I'm already in a pretty good shape. So what I'm going to do is just what comes instinctual to me, and that is to use this right here. So let's try it. Log base 2 of x minus 6 over, or sorry, it's going to be x minus 6 a times b, because we're adding. So it's x minus 6 times x minus 8 is equal to 3. Okay? Now in this case, how am I going to get 3 from a log? Right? The 1 was great because I could just do, if this was a 1, I'd just say, okay, log base 2, 2. And then I could just use my, this log. Here, that's not happening, okay? And I'm going to have a trinomial when this works out. So what I'm going to do, what I'm saying I'm going to do, is I'm actually going to go back to this log now, okay? This is still important. So I can say that, well, that's my c. And so if I put it back into this form, 2 to the power of 3 should give me that. So I'm going to rewrite this as x minus 6, x minus 8 is equal to 2 to the power of 3. Okay? And then I'm going to expand this multiplication. X squared minus 8x minus 6x plus 48 is equal to 8. 2 to the 3 is 8. Okay, now I'm going to bring this 8 over, and I'm going to see if I can solve for it. I'm going to solve this as a trinomial. Oh, sorry. 8x minus 6x is minus 14x plus 40 is equal to 0. Okay, I'm just trying to solve for x now. And we've done this many times. This is just factoring. This is there's no number in front of my x squared, so I'm going to use my product sum method. Two numbers that multiply to positive 40 and add to negative 14. And I can tell right off the bat, 10 times 4 makes 40, or negative 10 times negative 4 makes 40. When I add those up, I get negative 14. So here, my answer is x minus 10, x minus 4 is equal to 0. And therefore, x is equal to 4 and 10. Those are two options for x, okay? We did it. Excellent. Let's try I'm going to try one more. I'm just going to try one more. I think I gave you guys enough now to play with to kind of go and prosper. So here we go. I'm going to try. Sure, I'll just try this one. So I got 2 log base 4 x plus 4 minus log 4 x plus 12 is equal to 1. And listen, when you guys see these questions for the first time, you might just freeze and you might tense up and you might think that you can't do it. Just try stuff. Fail. Just try a method and see if it gets you anywhere, okay? And if it does get you somewhere, trace your steps and you'll learn. That's how learning happens. We learn by screwing up, and trust me, I've been there many, many, many times before. So let's try and attack this one. So what I'm noticing, just looking at this, is I've got the same base here, and I've got a 1, right? So I'm already thinking, okay, I know that I can replace a 1 with that. And maybe I'll do that right off the bat, just so it's really easy to work with. I also have a number in front of this log here, so that can become an exponent up there, which might come in handy. So I don't know how to. I'm just gonna use what I know, and I'm gonna try. So yeah, I think so. Okay, so I'm gonna bring this 2 back up, and I'm gonna use this identity. So log 4 x plus 4 squared minus log base 4 x plus 12. And then you know what? I'm going to replace this one with log base 4 of 4. Because that's what I can do using this law here. And now I have the same base, which is going to come in handy, I can just tell. So now I'm going to rewrite this using this identity. Log base 4 x plus 4 squared divided by x plus 12 is equal to log base 4 of 4. Now I can use this log because I have the same base for my logs. So I can ignore the log base 4 now and just rewrite this as x plus 4 squared, or x plus 4 times x plus 4, because I know I'm going to have to expand this, over x plus 12 is equal to 4. Now I'm going to multiply, I'm going to solve for x here, and I'm going to do it by getting rid of my denominator. I hate denominators with variables, so I'm going to multiply both sides by x plus 12. And I'm going to expand this. Now I'm going to expand all of this, and I'm going to move everything to one side, make it equal to 0, and I'm probably going to wind up with a trinomial that I have to factor. It's just, these problems follow such a pattern. You just kind of get used to what's going on. And you get there by doing a ton of them. So, x squared plus 4x plus 4x plus 8x, 4 times 4 is plus 16, is equal to 4x plus 48. 4 times 12 is 48. Now I'm going to move all of this over here, and I get x squared plus 4x. This is 4x subtract from that 8x. 16 minus 48, I don't feel like thinking, minus 32 is equal to 0. Now I have a trinomial that I can solve for x using my product sum, because there's no number in front of my squared term. No number other than 1. Two numbers that multiply to negative 32 and add to positive 4. Well, I can tell already it's going to be positive 8 times negative 4. So this becomes x plus 8, x minus 4 is equal to 0. Therefore, x is equal to either 4 or 8. Sorry, positive 4 or negative 8, my bad. And if you don't know how I got from here to here, you just need to go, I'll show you, gosh. I'm sure it's in another video, but, so if I have x plus 8 and x minus 4 is equal to 0, well, if I were to divide out x minus 4 on the first time round, I'd get x plus 8 is equal to 0, and then x is equal to negative 8. And then if I do the same thing by dividing both sides by x plus 8 the next time round, that goes away and I get x minus 4 is equal to 0, or x is equal to positive 4, okay? But that's explained in many other videos. Okay, let's do one final example. No, I don't know if we have to, but okay, one final example, just to drive it home for us. So let's say I have, this is from textbook example. So let's say I have log base 2 of x plus 3 squared is equal to 4. Okay, let's see what I know about this. I'm not going to be able to get 4 down to any of these two. 4 is not going to really help me. Okay, so, and now I'm looking over here because it doesn't seem like my laws here are really going to come in handy because I can't turn that into a log. So I'm already thinking, here. And when I do that, well, 2 is my base to the power of y is equal to x plus 3 squared. Now, when I first saw this problem, immediately what I wanted to do was bring that 2 down and then that divides, then I would divide everything by 2 and I get log base 2, x plus 3 is equal to 2. And then I applied this here. But that did not seem to work so hot for me. It only gave me one answer. So we want to keep our exponents up here when we're kind of in this situation. We have a square in this. It's kind of confusing, and in future videos I'll try and explain it better, but just for now, let's just play with it this way, okay? Where we keep the exponent up here, where it belongs. We like to work with the exponents up here, not down in front. So now I'm going to expand this x plus 3. 2 to the 4 is 16. X squared plus 6x plus 9 is equal to 16. X squared plus 6x minus 7 is equal to 0. Now I'm good at this. Is a trinomial. Two numbers that multiply to negative 7 and add to positive 6 is going to be positive 7 and negative 1. So x plus 7, x minus 1 is equal to 0. Therefore, my answer is x is equal to positive 1 or negative 7. Those are both scenarios that make this work. So hopefully that's enough to get you guys going. You just have to think a little. It's a puzzle. It's a puzzle. You just have to figure out the rules. This is the big rule that I've kind of discovered, other than this, is keep the exponents as exponents and work with them as exponents and expand out when you can. We should be running into trinomial situations at the end of some of these problems. I did my best. We'll try again.